In this video, I'll discuss how it is possible to create an electrical contact with an OFET and subsequently measure its properties. An electrical contact must be made to a power source and an ammeter in order to control the applied voltage and measure how this affects the conductivity. In an ideal OFET, the conductivity would remain low until the applied gate voltage reaches a specific voltage. When this voltage is reached, the conductivity should rapidly increase to a steady value. The problem with making contact is that a direct metal-metal contact has a habit of scratching the contact pads, and it is further difficult to measure whether contact has been made. Further, directly soldering an electrical contact is difficult because the solder does not adhere well to the surface. Several workarounds are possible, however. Gallium indium eutectic, a liquid metal mixture, may be applied and contact may be made through it, or a silver glue or paint used. A final method is to use conductive silver zebra elastomers. This is my preferred method. In all cases, the precise thing used will be linked in the description below. Indium-gallium eutectic is a liquid metal mixture. It is very conductive and may be applied directly to a surface via syringe. It is instantly conductive and can be contacted directly with metal contacts. While this contacting method is quick to apply and easy to use, it is relatively easy to short contacts. That is, connect different contacts in an undesirable way. Further, the eutectic can cause damage to the lungs through prolonged or repeated exposure. An alternative method is to use silver glue or silver paint. Here I am using Chemtronic's CW2400, although I believe there may be better glues for this job. In order to apply it, the two components must be mixed in equal parts, then applied to a surface, then a wire attached to the glue. The substrate must then be annealed for 10 minutes at 100 degrees Celsius. After this is completed, the wire is fixed in place and may be used to contact the surface. The silver epoxy I'm using here is significantly less conductive than the gallium eutectic, and as such it may not be appropriate for high conductivity applications. Further, the epoxy is easy to short and takes time to cure. The final method is to use a zebra elastomer. A zebra elastomer is a sequentially layered material of silver foil and polymer film. These are stacked to be conductive in two directions and insulating in the other. These may simply be placed on a surface and conducted through. Here I am doing this with equally separated pin connectors which happen to match up with the substrate I am using. One has been attached to a breadboard and the other connected to wires. They have magnets which press on the elastomer to make contact. The major downside to this method is the elastomers are expensive, costing approximately €10 each if bought in a pack of 100. Further, they are not broadly commercially available. I had to order these by contacting the supplier and waiting 3 months for their delivery. Now that the OFET has been electrically contacted, it is possible to measure the OFET properties. The OFET I am working with is produced with electrodes positioned according to a low-density mask provided by Oscilla. The source and drain contact pads are on the top and bottom, and the gate may be contacted on the side. I am using zebra elastomers for this, with contact to the gate made through the magnet of the clip. In order to measure the electrical properties, I'm using a Keithley 2230 power source and a Keithley DMM6500 multimeter. These are connected to a computer, and a MATLAB script is used to coordinate the measurements. I've shared this script on GitHub, linked below. To get a full range of measurements, it is necessary to swap input wires to switch between positive and negative gate potentials. This is because the power source I'm using can only operate in positive mode. Further, it is necessary to change the connections to change the specific gate which is tested. I'm using a substrate manufactured via the Oscilla template, which has 5 different gates of width 30, 40, 50, 60 and 80 micrometer. After the film is measured, it is necessary to process this data. Currently I'm using a Python script for this, also shared on GitHub. The final data of a working P3HT OFET is now shown. This is from a spin-coated sample.